Good afternoon. Today we are going to be taking a look at section 9.3 in Algebra 2, Graphing General Rational Functions. We're going to be extending a little bit from what we were doing in 9.2 with some changes in our graphs. So, similar to what we saw last time, our form is not changed. P of x and Q of x are still going to be polynomial functions. Now don't get scared by all of this over to the right. We're just going to take some basic pieces from this to help us find out some answers. For instance, a and b are just values of our coefficient in front of our first terms in this case. So my a value would be 2, my b value would be 4. Okay. My m and n are just taking a look at the exponents of those said first terms. So my m value would be 2, my n value would be 3. Those will come in handy a little bit later as we work through some of the intricacies of graphing these types of functions. So for 1 through 4, we're just going to get some practice at looking at the asymptotes, and then we're going to allow the equation itself to give us some better information. For instance, remember from last section we talked about the fact that where if it looks like our graphs are starting to hug a certain line that they're not going to go across, we can draw an asymptote in there. Now remember, it needs to be, however, that we have a couple of different branches that are hugging up against it. Because as I draw these in, some of you are probably looking at this saying, well, why isn't there one here across where there's -1? Again, the asymptote's job is to force your graph to stay above or below that point. This graph kind of does that on its own, so I really don't need it. So again, if you look at our red asymptote here, our horizontal one, that's a y asymptote, where y would equal 1. My asymptotes that are vertical are my x's. So we have one at x equals 1 and x equals -1. And that's all we're attempting to do here. So again, we can have one that's kind of like an upside down bell curve. I have no vertical asymptotes because my graph never really stops. And again, here I don't want one at 0 for the same reason I didn't want one over here. The curve kind of takes care of itself where this is more forceful. So I get y equals 2. But again, we can have several asymptotes within any graph. And again, we label the horizontals with y equals and the verticals with x equals. Now this one, you're like, well, that curves and takes care of itself, and so does this. Not quite as obvious maybe, but we still have an asymptote. Okay, so that's one skill we can use to help us if we have a graph. Well, what if I don't have a graph? What can I do to make a very accurate graph of something? Well, if I work my way up, I notice a couple of things under this characteristics section. One says x-intercepts are the real zeros of p of x. So if you look at the top of your paper, you notice p of x is your numerator. So for x-intercepts, we're going to set the numerator equal to 0. That's how we're going to find our x-intercepts. Then it says the vertical asymptotes is the real zeros of q of x. Well, we mentioned this back in 9.2. We're always going to set the denominator equal to 0 to find any vertical asymptotes we may have. However, the horizontal asymptotes are going to start changing a bit depending on what the format of our function is. For instance, m and n, we talked before about that being our first term's degree or exponent, and n being our second term's degree or exponent. Because remember, it looks like this. We're just looking at the exponent of the first term. If my m value is less than n, in other words, if the exponent in the denominator is bigger, I have a horizontal asymptote at y equals 0. If they have the same exponent, I just divide the coefficients, just like we did in the last section. So this is like what we were doing in 9.2. Okay. Here, if my denominator exponent is larger, okay, would be this situation. And if my numerator exponent is larger, if m is greater than n, then I have no horizontal asymptotes. Now I can look at this from my graphs, but I want to know this stuff before I ever start. So I start to look at this first one. Okay, number 5, y equals 4 over x squared plus 1. x-intercepts. Well, it says set the numerator equal to 0. Well, that can't happen. 4 doesn't equal 0. So I'm going to have no x-intercepts. Vertical asymptotes. Set the denominator equal to 0. And I work on trying to solve this. And I take the square root and I go, uh-oh. X equals positive or negative I. Well, I can't graph I. It's not a real number. So if that happens where you can't factor it or you get an imaginary number, that's going to be none. So I don't have any vertical asymptotes. It's like, this is kind of weird. Horizontal asymptotes. Well, you're like m and n. Well, my exponent in the denominator is 2. Well, I don't see any exponents up here. Well, remember, if I don't see one, I can assume there's nothing there. It'd just be a 0. So my m would be less than my n. M is less than n gets us to this point where y equals 0. So that's going to be, so the only information I have so far out of all of this is that I have a horizontal asymptote at 0. You're like, well, how's that work? That seems kind of weird. Well, let's take a peek and see why that happens to be the case. So I got 4 divided by, and again, if you ever have a term that's more than one term, so here I have a binomial, I want to make sure that I put that in parentheses to make sure the calculator does the order of operations that I want. When I graph it, I'm like, oh, now I see why that is. This graph doesn't have a break. No vertical asymptotes. It never crosses the x-axis, so there's no x-intercepts. But it does seem to hug up against the x-axis, which is my y equals 0 horizontal. She's like, well, how do I pick what points to use now? Basically here, I'd look towards the middle, because you'll notice they're symmetrical. So if I plot the points, 1, 2, 0, 4, and I'm going to get this bell curve shape with my points. That hugs the axis, comes up, comes down. So this, when I graph it, is giving me an idea of it, what it looks like, but it's not the be-all, end-all. Do not just sketch, okay? And then again, domain goes with my x's, range goes with my y's. So my domain goes with my vertical asymptote. Well, what if I don't have any? Then it's just all reals. There are no restrictions. My range goes with my horizontal asymptotes. I have a y value of 0, so my range is all reals not equal to 0, because I'm never going to get 0 out of this with the way the expression is set up. And that's the same way all of these are going to work. So if I move up a little bit here to the last one on the front, I do the same thing, x-intercepts. Set the numerator equal to 0. I find out x is 0, so I'm going to have a point that crosses there. Vertical asymptotes. Set that equal to 0, get my x squared alone. Be careful here, especially if you go to a calculator, which you shouldn't have to for the square root of 4, but if you did, remember, anytime I take a square root and something can be squared, I'm going to have 2 answers. So I'm going to have vertical asymptotes at plus and minus 2. Again, I would suggest, as you get these, you go ahead and draw those in. Horizontal asymptotes, again, we're looking at the exponents. This time it looks like m and n are both 2, which means they're equal, which means we're going to divide the coefficients. So divide the numbers out front. 3 divided by 1 is 3. That's my horizontal asymptote. Lots of asymptotes this time. And the nice thing is, again, I can always check on my graphing calculator then to see what could be possibly going on here. I'm trying to get where I could get a little less of a glare. There we go. So again, 3x squared divided by, and again, anytime you have a binomial or larger, you want to make sure that you use parentheses. So I graph that. I see both of my vertical asymptotes, and I also see where my horizontal one would be. So I'm feeling really good about this. Now, how is this going to work this time? Because now there's a whole lot of asymptotes here that we've got to deal with. How am I going to figure out What points to plot? Well, like I said before, I want 2 to the left and 2 to the right of each one of my asymptotes. So I want the one at -4, which would be 4. I want the one at -3, which would be 5.4. -2 is my asymptote. Okay, -1 is at -1. 0 is at 0. 1 is at -1. So you're noticing I have a lot of points this time because 2 to the left and 2 to the right each of those means basically I'm looking at 8 points this time. May seem like a pain, but we have to be accurate. 5.4 and 4. Draw in my branches. And by golly, it looks just like the one on the graphing calculator. So kind of cool. One more to go. We're going to flip over to the back. Last one. Same idea though. X-intercepts. Set the numerator equal to 0. Yes, we're going to have to factor here. Multiplies to -3, adds to -2. It'll be -3 and 1. And set those each equal to 0. So I get x-intercepts at 3 and at -1. My vertical asymptotes, I set the denominator equal to 0. So x equals -4. Draw that in. Horizontal asymptotes, my m value is 2, my n value is 1. So m is greater than n. So if we take a quick flip back just to make sure, m is greater than n, I have none. So flip back one more time. And I just remembered I didn't do domain and range on number 6, but we will make sure to do it on number 7. So I start to look, and I want to make sure I'm doing this right. So I'm going to go ahead one last time here. Again, anytime we have more than one term, you want to make sure that you get those into parentheses, both in this case for the numerator and denominator. Go ahead and graph that. Okay, and this one looks kind of strange, but it makes sense. A couple of x-intercepts. I have a vertical asymptote. So again, here we want to get some values that are close. So if we go to -3, that's at 12. Now I can't quite fit that in. -2 is at 2.5. -1's at 0. We knew it was. 0 is at -0.75. 1, and we're just wanting to do it just enough that we can get an accurate depiction of what's going on. So last part here. Domain and range, again, domain goes with my vertical asymptotes. All reals not equal to my vertical asymptote. And finally, my range, I do not have any restrictions, so it's going to be all reals. I hope this has helped you out in getting ready with section 9.3. Again, if you have any other questions, you're going to need to come in, get some help on that. Thank you.